our last video, we saw how to find normal probabilities using StatCrunch. But what if you don't have access to a computer? Well, there is a way to do it without access to technology using a table of areas. But we're not going to have a table for every different normal distribution. Instead, we will have one table for what's called the standard normal distribution. And so, given any problem, we can convert to standard units by finding z-scores, and then use our standard normal table to help us find areas under the curve. Long ago, and actually not so long ago, technology was not readily available, and so this is how they had to find those probabilities. In this case, using technology is both easier and more precise. So I'll show you how to do this without the technology, but really you should be using StatCrunch to compute these probabilities. So what do we mean when we say the standard normal model? Well, that's the normal distribution with a mean of 0 and a standard deviation of 1. Like I said, there are tables that are going to give you the area under the standard normal distribution. So given any normal distribution that's not the standard normal distribution, I can convert a value to a z-score to determine its location in terms of standard deviations from the mean. That allows us to convert from any normal distribution to the standard normal distribution using the formula z equals x minus the mean over the standard deviation. Now, we've seen this formula before. However, when we saw it before, instead of using mu and sigma for the mean and standard deviation, we were using x bar and s. So we saw it in this form, with the line over the x and s, because we were dealing with samples. So let's look at the seal pups example again and see how we could use a table to find probabilities. Small newborn seal pups have a lower chance of survival than larger ones. Suppose the length of newborn seal pups follows a normal distribution with mean of 29.5 inches and a standard deviation of 1.2 inches. What's the probability that a randomly selected newborn seal pup is shorter than 28.0 inches? So our first step is going to be to draw a picture. So here's my picture. Again, I want to mark the mean. Now this is the picture that StatCrunch spit out for me, but I should, if I'm going to draw it on my paper, I want to mark my mean of 29.5 there. And then I want to shade the area that I'm interested in. Here I want to know probability that we're shorter than 28 inches, so I'm going to take 28 and shade everything to the left. That's smaller. Step 2 is to convert the information in the problem into a standard score, a z-score. So I'm just going to plug into my z-score formula. Here's my x minus the mean all over the standard deviation, and I'm just going to plug that into my calculator. That gives me a z-score of negative 1.25. My third step is to look for that z-score in the normal table and then use that to find my desired area. In this case, I'm going to look for negative 1.25 on my standard normal table. Now, the standard normal table that our book provides gives us the area from z all the way to the left of z. Okay, so it gives, in this case, exactly the area that we're interested in. This is called the cumulative probability. Now, be careful because some other z-score tables might give you areas between z and 0, or they might give you the area from z to the right. So you just need to pay attention to what kind of table you have. All right, so we want to look for negative 1.25 in this table. To do that, we're going to start by looking in this first column, and I'm going to look for the first 2 digits in my z-score. That's the negative 1.2. It's right here. Now I'm going to scroll across the top row to find the second decimal in my z-score. It was negative 1.25, so I'm going to look in this 0.05 column, and I'm going to find where those two, that row and column meet. So there's the column, and here's the row, and they meet here at 0.1056. So that's telling me that the area from negative 1.25 to the left is going to be 0.1056. And that's what the calculator gives me in StatCrunch as well. All right. Okay. Here you can see on the bottom right, we've computed the probability that x is less than or equal to negative 1.25 in the standard normal distribution, and compared that to the probability that x is less than or equal to 28 in our distribution of seal pups.